Okay, guys, can you guys hear me?
Yes.
All right, so let's give it one more minute while we're receiving more attendance. All right, one more minute, because today is our first lecture. Always we have some new student, they have some technical issues, so on and so forth. So let's give it one more minute. All right, it's 7:01, so let's get started. Okay, guys, welcome to this 2021 AMC 12 AMY Core Preparation Bootcamp. So before we get started, as a common practice, I'd like to give you guys some short and brief introduction about our lecture, pretty much focus on the organization, the homework, so on and so forth, because we always have a new student joining us. So let's just take this opportunity to make sure everyone is familiar, okay? So this is a short and brief introduction. So strategy. The purpose of our course is trying to give you guys an overview for the most important concepts for the AMC 12 and AMY. Because generally speaking, we have like so many concepts in the AMC, right? It is very challenging, if not impossible, to cover all those concepts within only 10 lectures. So what we're going to do is we're trying to make up the most important, the most common strategies that we like to introduce for the AMC and AMY exam. And also, we have like so many problems for the AMC, so it is impossible for us to cover them all. So on the contrary, the most important thing for our lecture is trying to teach you guys the strategy, the thinking process, especially when you see a type of problem, what is the common approach? So having something more kind of like a conditional react is going to be more beneficial rather than just try to see as many problems as possible. All right, so that's the basic strategy, the fish and fishing. Try to teach you guys how to, how to think when you see like different problems. All right. The second one is the interaction. These days, due to this COVID situation, pretty much most of the lectures goes onto online, right? So it's barely, these days is more kind of like a common that we see each other over this internet. I think that interaction is actually very important, regardless you're doing this face-to-face to our teacher, or we're doing this over the Zoom or Skype. So in order to try to help you guys have more interaction, as much interaction as possible, I wish you guys to, basically try to speak out, whatever you think. As long as you have any questions, you have any objections, always interrupt me. So you're gonna see I'm actually a very casual person. You can always interrupt me in the middle. There are two ways for you to participate in this interaction. The first one, which I highly recommend, is you can actually unmute yourself and directly speak out whatever you think. By default, as long as you enter into this Google, like kind of like a Zoom classroom, you'll be automatically put into mute, but you can always unmute you and ask whatever question. So in that case, everyone will be able to see your question. They might give you some feedbacks. Well, the second way, if you want to do a little bit low profile, what you can do is you can chat with me. So I hope you guys are familiar with the Zoom application. If you're not, so in your control console, on the very right, you're gonna see three dots saying more, right? You click that three dots. The first option from the pop-up menu will be chart, right? Click that one, you're gonna be able to see our chat board. So while I'm doing this lecture, I'm actually monitoring the chat board in a real-time basis. So anytime you have any questions, you can feel free to post your question into the chat board. You have two ways to communicate with me. First one, which is also what I more recommend, is to chat to everyone. So by default, right, the receptant is actually everyone. Everyone will be able to see your question and will be able to give you an answer. Well, if you feel a little bit shy, you can actually choose my name from the drop-down list. In that case, you're gonna have a private message to me. So I won't be really charging you, for your answer, for your question, so on and so forth. So as long as you find out the most comfortable channel, in order to talk to me is good enough. All right. The last one is the homework. So I do believe, mathematics is actually a very practical, kind of like a practical thing. If you only, like listen to what I say, watch my videos, so on and so forth, it might not be so beneficial. So every single lecture, we're gonna give you guys some homework. Roughly speaking, like 3 problems. So you have like 1 week to finish up all those 3 problems. And you can upload it into the Google Classroom. I have already invited every one of you to the Google Classroom where you can download the homework, you can submit your answers, so on and so forth. And for the next lecture, I'm gonna be inviting the student to give us a very quick walkthrough for the assignment. Because these days, if you only know something, it is far away from enough. The most important thing is you not only know something, but also you can present it in a very proper way, right? Especially if you guys want to go to like the big techs, Google, Facebook, Amazon, so on and so forth. Or the code interview, they want to have the whiteboard. It means that not only you can type the code on your computer, but also you can think aloud. Basically, walk the interviewer the entire process. So the same thing, Rome wasn't built in a day. All those kind of practice can be gradually by grad. All those kind of practice should be kind of like taking place every place, right? So as long as you have this opportunity, you can always, try it. So while we're talking, the student have, can I use Mandarin to ask a question? I think you can type, I can understand, but I don't think most of the students, they will understand the Mandarin. Pretty much everyone here is like, I think English is more straightforward, but of course you can type Mandarin and you can try, right? You can try to ask some Mandarin in case everyone can understand. But I think English is the preferred language, like the official language for this lecture. All right. All right, and the last one before we get started is kind of a quick syllabus for this our lecture. Our lecture actually contains 10 subsessions, and this 10 subsessions, like I mentioned, is going to cover the most important thing for the entire AMC 12 and AMY. So we break them into such 4 different categories. We're going to spend the first 2 lectures focusing on the 2D geometry, 3D geometry, and coordinate geometry. AKA, we cover all the geometry-related concepts. And then the other 2 lectures covering the most general algebra topics, something like the sequence, something like the inequalities, so on and so forth. And also, we're going to spend 2 more lectures talking about something specifically for AMC 12. That is the polynomial, advanced functions, trigonometry, and complex numbers. Especially, you're going to see some of them, especially the advanced function and the complex numbers, you can only see them in AMC 12, or you won't be seeing them too much in the AMC 10. So this is actually kind of like a difference between these 2 exams, and we like to put some emphasis in these 2 sections. And then we're going to spend 2 lectures focused on accounting and probabilities, and 2 lectures talking about the number theories. So generally speaking, our 10 lecture will cover the most important concepts for these 4 major sections: geometry, algebra, counting and probabilities, and also the number theory. All right, just want to give you guys some quick overview of what's going to happen for our lecture. And if you have any questions, please always let me know. All right. Any questions so far? So far, so good? All right. Okay, so let's get started. Let's go to our first lecture, 2D geometry. Okay, this is our lecture number 1, 2D geometry. 2D geometry is actually a very important concept for the entire AMC. And you know what, if you do some statistics to see, okay, how many problems are tested for the 2D geometry, how many problems are tested for the, let's say the algebra, so on and so forth, you're gonna find out for the entire AMC and AMY history, there are more than 47%. There are more than 47% problems that are actually tested for the 2D geometry. So that being said, 2D geometry is actually a very important concept. We need to put some focus for this part. All right, so before we jump to the problems, I always like to spend some quick time talking about some basic concepts for this section, just to give you guys some wrap up, some important things that you need to know for the AMC 12 and AMY, especially for the 2D geometry section. All right. So our first section is always concepts. The first one is the basic triangle inequalities. Okay, for any given triangle, you have the three sizes, A, B, C. Then automatically you should have a relationship for the three sizes, right? A plus B is greater than C. A minus B is lesser than C, right? So I think this is like a very common sense. And at the same time, there's another very important inequality relationship for any triangles, that is our sine and cosine. So sine theta, let's say this is theta, cosine theta, as long as you have a triangle, you have a theta, you'll be able to know, okay, sine theta and cosine theta, their absolute value is always between 1 and 0, right? This is the basic concepts. That being said, as long as you see a triangle, if the question asks you to bring up some inequality relationship, right? The first reaction is try to think about the triangle's basic inequality and also the trigonometry. That's our first thing that you guys need to know. Second, very important thing is the Pythagorean theorem, right? This is actually something we know from pretty much, from elementary school, right? When you have a triangle, as long as the right triangle, A, B, C, you're gonna have A squared plus D equals to C squared, right? And also vice versa, right? If you have a right triangle, you'll be able to have such relationship. If you have such a relationship, you'll be able to define, okay, so this is a right triangle. Well, instead of testing you this Pythagorean theorem directly, AMC really likes to test you something like this, what we call the Pythagorean triple. So sometimes the question won't mention we have a right triangle. Well, on the contrary, the question will give you the three sizes, the measurement of the three sizes. Then you need to know, as long as you see these three sizes as a conditional react, you will find out, okay, this is actually a right triangle. So the Pythagorean triples you need to know are something like this. 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 20, 21, 29. Okay, try to remember this. These are the most commonly seen Pythagorean triple. As long as you see the three sizes goes like this, then automatically you will realize this is actually a right triangle. Actually, this is a very common strategy for most of the rotation and reflection related problems. So there are a type of problem. In a problem, the question will ask you to rotate part of the shape from one place to the other, and then try to use this kind of relationship to figure out some calculation. In that case, most of the time, I'll say 99% of the time, as long as you rotate the shape from one place to the other, you will automatically create some Pythagorean triples. And then using the Pythagorean triples, aka the right triangle you just created, you will be able to do a lot of calculations. So just bear in mind, sometimes as long as you see these numbers, this is a signal of the right triangles. All right, so let's continue. Number 3, that's the important Heron's formula. Heron's formula is basically doing what, all right? As long as you have a triangle, as long as you have three sizes, you will be able to determine the area of this triangle, right? P is A plus B plus C divided by 2, and your area will be equals to P, P minus A, P minus B, P minus C, right? I think this is something quite common. Everyone should know that. Here, this is only tiny trick I want you guys to remember. Most of the time in the AMC exam, or including AMY, the question will give you a triangle with 3 sizes, A, B, C. So these numbers are given. And for some reason, during your calculation process, the question will ask you to determine the height of this triangle. Okay, there's a lot of problems basically go for such a routine. Okay, how to determine the height of a triangle as long as the 3 sizes are given? There are 2 common strategies. Common strategies. The first strategy is actually using the Heron's formula, right? As long as you have 3 sizes, you'll be able to know the area of the triangle. Plus, if you know the side of one bottom, you'll be able to determine the h, right? Well, I think even though this is a 100% correct strategy, but there are some limitations when you're using this strategy. So by the way, student asked, what does S stands for? Okay, S stands for the area. In our math territory, there are 2 ways to determine the area of a triangle. Let's say triangle ABC. Sometimes you can use ABC, then you'd use a kind of like a square bracket. That's one way to represent the area. Or you can directly use S, triangle ABC. So these 2 denotations, they're exactly the same. The only difference is kind of like denotation, right? So most of the teachers will be understandable for either of them. So you choose whatever you like. I think AOPS likes to pretty much take the ABC, like a square bracket. Well, if you go to some European textbook, they're probably going to choose this S. So anyone, it's the same thing, no difference. All right. So any question, just post it into the group chat. I'll be able to monitor it and give you an answer in a real-time basis. Okay, so let's continue. In my previous, previously we mentioned that as long as you have 3 sizes, the question asks you to determine the height. So you can use the Heron's formula, which is 100% correct. However, there are some limitations. Think about it. If the problem gives you a lot of weird numbers for the 3 sizes, let's say under root 2, under root 17, I don't know, under root maybe 29, for instance, okay? Using this way, you're gonna have to define P first, all right? P is gonna be a very nasty number, 2 plus 17 plus under root 29, right? So that being said, as long as you calculate the value for P, you wanna determine the area for this triangle. This is gonna be a nightmare. Under this under root, you're gonna have a P, which has a bunch of under roots, and P minus A all the way to P minus C. Your calculation is gonna be a disaster, right? Even though for sure you'll be able to calculate it, but this is not a correct, this is not the best option to minimize all your troubles. So that being said, this is actually a second way, which is also very preferred from the AMC exam is, as long as you see a weird number for ABC 3 sizes, the best way to determine the height is using the double Pythagorean theorem. What is the double Pythagorean theorem? Let's say in this way. I have A, I have B, right? I have C. I want to determine the value for H. In that case, I'm going to do something like this. I'm going to let this part equals to X. So this card is going to be C minus X, right? For sure. So you will be able to have such a relationship, A squared minus X squared under root equals to B squared minus C minus X squared under root. Is that right? Means that you're actually determining the height for the 2 sides. Of course, when you have this, you will be able to determine the value for X, right? And taking from there, you'll be able to determine the value for H. Okay, trust me, even though these 2 methods are exactly the same, right? There's nothing too tricky. However, the second way is going to help you significantly when you're dealing a lot of weird numbers. Let's say when you have a lot of weird numbers here, here, and here, when you plug in here, see, most of the time you're dealing with some whole numbers, right? So you don't have to struggle too much how to determine the under root under the under root. So trust me, AMC actually from time to time test you such a strategy. The question will give you a lot of weird numbers and ask you to determine some height or so ever. Try to use the second one rather than directly using the Heron's formula. Okay, so far so good. So let's continue. This is actually number 3. Let's go to number 4. The number 4 thing you need to know is the famous angle bisector theorem. Angle bisector theorem. As long as you have a triangle, ABC, as long as you have an angle bisector, right? Let's say AD. AD is angle bisector. Then you will be having what? AB over AC is equal to BD over DC, right? So these days, trust me, as long as you see the angle bisector, no one is testing your angle bisector to break it into 2 separate angles, of course. However, something more important these days is as long as you see the angle bisector, you must use the angle bisector theorem. This is pretty much a conditional react, okay? Try to remember, this is a conditional react. In the entire AMC and AMY territory, as long as you see the angle bisector, 99.99%, you're going to use the angle bisector theorem. Try to remember this. This is very important. All right? So this is number 4, okay? Let's go to number 5. I assume that you guys already have some basic knowledge since you're preparing for the AMC 12, so I don't have to expand too much. I just want to list out all the important things. But if you do have any questions, you can always reach out at me individually or from the WeChat or from this, what should I say, like WeChat or our Zoom chat. I'll be able to give some further elaborations. All right. Number 5 is power of a point. This is more like for a circle, right? As long as you have a circle, you will be able to have 3 different theorems. So power of a set is not only one theorem, it's actually a set of theorem, which actually contains 3 subtheorems. The first one is what we call the chord theorem, A, B, C, D, if this is E, okay? This is what we call a chord theorem. As long as you have 2 chords intersecting each other within a circle, you will have AE times EC equals to BE times ED, right? The 2 chords intersecting, you will have such a chord theorem. And then second one is the tangent secant theorem. Let's say A, B, C, D, right? AB is a tangent, right? Then as long as you see a tangent, you'll be able to see AB square equals to AC times AD, right? AB square equals to AC times AD. Here, I want to have a quick side note. A side note. Again, 99.99%. As long as you see a tangent to a circle, as long as you see a tangent to a circle, probably you're going to do one of the 3 options. One of the 3. The 3 options. First one is connect center to the tangent point. Connect center to the tangent point. Second is connect 2 centers. Later, I'll show you what does it mean, okay? Second is connect two centers. The last one is the tangent second theorem. Tangent second theorem. So what I'm trying to say here, first of all, as long as you have a line tangent to the circle, 99.99%, you're gonna do a connection between the center of the circle all the way to the tangent point. Because as long as you do a connection, this is gonna be perpendicular, right? This is gonna generate a perpendicular thing. Second, as long as you see two circles, they're tangent to each other. Two circles, they're tangent to each other. They can be outside, right? Or they can be inside. It doesn't matter. Always connect these two circle centers. First of all, the distance between these two circle centers will be either big R plus small r or big R minus small r, right? This is quite understandable, right? Also, a very important thing is if you want to make a tangent line to these two circles, the segment created between these two centers will be perpendicular to this tangent line. Is it right? This is actually the second important thing. All right? And the last important thing is, as long as you see this tangent to a circle, most likely you're going to use the tangent secant theorem, which is the one we just mentioned from here. Okay, so these are actually based on the analysis for all the existing AMC exams. So this is pretty much three major directions that you want to do as long as you see tangent in the AMC exams. All right, so let's continue. The last one, this is number one, right? This is number two. And the last one is actually secant, right? Secant theorem. A, B, C, D, E. You can have AB times AC equals to AE times AD. Okay, this is the basic power of a point that you need to know. Let's go to number 6. Number 6 is the famous Ptolemy, right? Ptolemy theorem.
Sorry for the interruption.
I'm sorry?
Sorry for the interruption.
Yeah.
So the BCD can be any point on the circle. So D has not to be the diameter or whatever.
I'm sorry, can you say that again?
For
yeah, they're
point.
actually any kind of, yeah, as long as you have like two lines cutting for the entire circle, they can be whatever points.
Okay, sure, thank you.
Okay, no problem, sure. Any question, let me know, okay? Okay, now we come to Ptolemy. Ptolemy is what? As long as you have a quadrilateral, which is inscribed for circle, or we have a more professional word is the cyclic quadrilateral, right? Let's say A, B, C, D, right? So you'll be able to have AB times DC plus AD times BC equals to AC times BD, right? This is the Ptolemy theorem, means the sum of the product of the opposite two sides will be equal to the product of two diagonals, right? This is the Ptolemy theorem. As long as you have a cocyclic quadrilateral, you'll be able to have such a relationship. And also vice versa, right? The inverse theorem is also valid. As long as you have a quadrilateral, you have such a relationship. The sum of the product of the opposite two sides can be equal to the product of the two diagonals. So this is going to be what? A cyclic quadrilateral. All right. So this is number 6. Number 7 is the most important Stewart theorem. Stewart theorem says what? As long as you have any kind of triangle, A, B, C, D, let's say this is C, this is B, this is length A, this is M, this is N, right? You have 5 different segments, right? And this is actually D, okay? All those segments actually have a relationship, right? It means that even you have a random triangle, so the relationship for this 1, 2, 3, 4, 5, because M is actually M plus N equals to A, right? You can just take A, it's not so important, right? We can say you have 5 different segments in this graph. There's a relationship for this 5 segments. So what is the relationship? Is M, A, N, D, A, D equals to B, M, B plus C, N, C, right? So these are the relationship between these 5 different segments. As long as you know 4, you will be able to determine the last one. Is that right? So this is the Stewart theorem. This is actually a very generic theorem. It means that as long as you have a random triangle, you don't have to have a super special triangle, quadrilateral, like equilateral or isosceles, so on and so forth. Just like a random triangle, you should have such a relationship. And how to remember this? You have something fairly quick. You can remember, because like the Stewart theorem is kind of complicated, right? How to remember? You can remember in such a way. A man and his dad put the bomb in the sink. You can take it as a shortcut how to remember such a theorem. You can always try to recite it from time to time, right? Like a man and his dad put the bomb into the sink. Always do this and you'll be able to remember this. Yeah, of course, don't say that when you cross the border, right? So just always try to remember this in your mind. This is like another way how to remember the Stewart theorem. All right? The Stewart theorem is kind of a little bit too generic. Listen this way, right? So sometimes students tell me, hey, Alex, I can't remember this. This is too complicated. But do I really have to remember the entire Stewart method? If you can, that's fantastic. If you can't, no worries. There are actually 3 specific scenarios that you need to remember. Okay, if you do not want to remember the generic Stewart, but there are at least 3 things you need to remember because AMC tests it from time to time. So I will say this is 7.1, 7.2, 7.3. These are considered to be the specific scenario of the Stewart. The first one is when AD is angle bisector. So at this moment, AD is not a random segment, right? AD is a specific segment, which is the angle bisector of angle BAC. In that case, AD can be written as under root AB times AC minus BD times DC. This is the famous angle bisector length formula. Angle bisector length formula. Okay, this means this is a specific scenario. AD is the angle bisector. Second specific scenario you need to remember is when AD is the median. Okay, AD is no longer angle bisector, but it's not a random segment neither. This is the median on the BC side. In that case, you're gonna have 2AB square plus 2AC square equals to BC square plus 4AD square. Still, you will be able to determine the length of AD using AB, AC, and BC. This is the famous median length formula. Okay, median length formula. The last one you need to remember is when AB is equal to AC. It means this time AD can be a random segment, I don't really care. However, AB equals to AC means this is an isosceles triangle, right? As long as you have an isosceles triangle, you also have something more straightforward, which is AD square equals to AB square minus BD times DC. Okay, like I said, if you can remember Stewart, that is fantastic. If you can't, it doesn't matter. At least you need to know these 3 specific scenarios, and they are more meaningful for most of the AMC exams. All right, this is our number 7. Let's go to our number 8. Our number 8 is actually our famous sine law and cosine law, right? Cosine law. Sine law will be A over sine A equals to B over sine B equals to C over sine C equals to 2R. 2R is what? 2R is the R is the radius of the circumcircle, right? A, B, C, this is R. This is the famous sine law. Cosine law is C squared equals to A squared plus B squared minus 2AB cosine C, right? A, B, C, A, B, C. This is our cosine law. So trust me, sine law and cosine law, they're so important. And later I'm going to show you actually 95% of the relatively difficult problem will be all using cosine law, especially cosine law to solve it. Later, I'll give you guys a quick summary and you'll be able to see why cosine law is like so important. All right. And this is number 8. Let's go to number 9. Number 9 is something very conspicuous and also very important. If I have 3 mediums, they will be intersecting with each other, right? A prime, B prime, C prime, AA prime, BB prime, CC prime, they're all mediums. So automatically you will have what? If this is O, AO over OA prime is actually 2 over 1. Is that right? The medium will cut the centroid, right? The O is what? O, what we give a name is centroid, right? 3 mediums will be intersecting each other at a point. We give a name, centroid. The centroid will cut the medium into 2 to 1 part. Is that right? This is actually something very important, and AMC actually tested from time to time. All right? So let's continue. This is number 9. Let's go to our number 10. Number 10 is actually the Menelaus, right? Menelaus. This is something very important. In our geometry section, we actually talk about it so many times. Menelaus. If you have ABC as what kind of triangle? You have a transversal line, A prime, B prime, C prime. You cut the 2 sides of this triangle. Then you will be having BA prime, A prime C, CB prime, B prime A, AC prime, C prime B equals to 1. Is that right? This is the Menelaus. Trust me, Menelaus is actually so important for Amy, and Amy actually tested so many times. Normally, when Amy tests Menelaus, it pretty much focuses on problem roughly number 5 to number 7. Okay, you won't see Amy tested for 2 like number 12, number 13. No, pretty much number 5 to number 7. It means that this is a basic concepts for the Amy. AMC doesn't test it too much, but Amy for sure will test it. These will be considered as an easy peasy theorem for Amy. Everyone needs to know. All right, that is for Menelaus. Yeah, for our regular lecture, we spend a lot of time talking about all those kind of things, but for our boot camp, we're just gonna do it fairly quick, okay? And number 11 is the Siva, right? As long as you have Menelaus, you should have Siva right away. Siva is something like this, A, B, C. Within the triangle ABC, you find a dynamic point O, right? And then you make 3 lines, okay, AA prime, BB prime, CC prime. They're intersecting each other at O. Then automatically you should have AC prime, BC prime, BA prime, A prime C, B prime C, AB prime equals to 1, right? This is the basic form for the Siva. Okay? And this is number 11. Number 12. Number 12 is pretty much talking about this quadrilateral and also the polygon. So trust me, even though AMC tested the polygons, the hexagon, octagon, right, and the quadrilateral from time to time, but they don't really use a lot of flowery properties for these polygons. Most of the time, the question will ask you to break these polygons into several triangles, and you still will be able to do all your magics within the triangle. Okay, so that being said, as long as you see polygons in the future, don't be scared. Break them into triangles. At the end of the day, AMC will be testing you all those flowery properties in the triangle rather than any kind of this polygon, hexagon, so on and so forth. Okay, so far so good? Okay, number 13 is actually the similar triangle and congruent triangle. So these two parts are pretty much a twin brother, right? As long as you know triangle, you will know the congruent, and then you go to the similarities, right? So try to understand what is the property and also determination rules, right? What is the property for all those similar congruent triangle and how to determine if two triangles are similar or they're congruent to each other. All right. And there are some, number 14, okay. Also, there are some kind of advanced theorems in circle. While AMC won't test it so directly, some AMY problems, if you know it, you can figure out fairly quick. But if you do not know them, that's not going to kill you. You can always do some basic calculation from scratch. So due to the time constraint, we don't really unfold it too much, but I would like to list out all those theorems. If you have some time after the lecture, you can do some Google search. Okay, so these are advanced theorems in a circle. We will cover them in our regular lecture, but here we don't have time to do that. So the first one is the butterfly theorem. And then Simpson theorem. Everst-Simpson theorem. Davis theorem. And chicken feet theorem. So these are some of the kind of advanced theorems, but AMC won't test you too much directly, but AMY sometimes they will use some of the conclusion to ask you for something. Again, if you're not familiar with the theorem, like for the official solution, they will always try to prove it from scratch. So you don't have to be so worried, but if you know it, you can actually save a lot of time. You can just directly jump to the solution fairly quick. All right, I think that being said, those are pretty much the most important theorems that you need to know for the AMC and AMY. All right, and moving forward, we're going to go to some typical problems. Second part, we're going to go to some typical problems. Actually, there are so many concepts for the 2D geometry, so we won't be able to cover them all. But I think there are some very important things, especially relatively difficult problems. We'll be testing you kind of these theorems from time to time. So think about it. For the entire geometry, for the entire 2D geometry, they basically ask you three things. One is to determine angle, right? Determine the measurement of an angle, or determine two angles that are equal to each other, or one angle is twice or three times of the other angle. The angle relationship. Second one is the side relationship, right? Two segments that are the same, or one segment is two times or three times of the other segment. But nevertheless, it's a relationship between sides. And the third one is area or volume, right? I give you a shape. If this is a 2D shape, try to determine the area. If this is a 3D shape, maybe they can ask you to determine the volume. Think about it, our entire geometry is nothing but this. They're not, so they won't be asking you too much over than this, right? And more specifically for AMC, okay, /Amy, same thing. They won't test you too much for the first one. If you do some analysis for all those AMC and Amy exams, you're gonna find out they won't ask you too much about the angles. Why? The reason is fairly straightforward. In order to determine the angle, you can always guess. Why? AMC is a multiple choice, right? They won't ask you to provide all their solution process. As long as you can guess out the answer, you're good to go. If a question asks you to determine an angle, most of the time, AMC would like you to do some trigonometry analysis, right? And then using the trigonometry to determine what is the angle value. So that being said, the final answer will be nothing but 0 degrees, 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75 degrees, 90 degrees. That's it, right? Because they ever have like 37, 67 degrees. You have no way how to determine the trigonometry value and then find out what is the angle. That is for one thing. Second thing, in the worst case, you have your protractor, right? Try to use the protractor to measure it, and then from A, B, C, D, E, pick up whatever reaches the closest. That's it. So that being said, AMC already knows that people will have such a trick, so they won't test you too much for the angle. Well, if you don't test it too much for the angle, actually it only focuses on the remaining two parts, side and area. You can check out all your AMC exam. Pretty much most of the problem is asking, most of the geometry problem is asking you, what is the measurement for side? What is the measurement for area or volume? Okay? And if we're on the same page, side and area is the way that AMC tests you from time to time. What is the most powerful strategy to solve the side and area related problem? Today, I can tell you, that is cosine law plus some of the Pythagorean theorem. Trust me, you go to all the AMC exams, 95% of the problems are actually using the cosine law plus the Pythagorean theorem, sometimes also having some similarity. Let's say there's 3, okay? Cosine law plus Pythagorean theorem plus the similarity. These are the 3 similarity. These are pretty much the 3 musketeers in order to solve all those kind of AMC side and area related problems. Trust me, that's pretty much the case. And sometimes you're going to see this problem in triangles. Sometimes you're going to see this problem in circles. Today, I'm going to give you some sample questions, pretty much the most important, most typical sample questions, talking about triangle-related problem using the sine law, using the cosine law, and also the Pythagorean theorem and similarity. Also, the other one is actually using circle, using all those technologies in the circle. Sometimes you're going to find out, okay, if you see one or two problems, you'll be able to see, okay, this is a common practice for most of the AMC exams. As long as you know one, you'll be able to know the others. All right, so these are the two major types I like to talk about for today's lecture, sample problem part. Okay, don't say too much. Let's jump to the first part. Using this is 2.1. Using the cosine law, similarity, Pythagorean theorem in triangles. Okay, let's have a look at our first problem. Okay, the first problem we're looking at is a problem from 2018 AMC 12A, question number 20. Okay, these are the real problems we're going to use to demonstrate our strategies. So let's have a quick look at for the problem. The problem says you have a triangle ABC, which is an isosceles right triangle. Try to mark them out. Isosceles and right triangle. The question gives you the two sides, AB and AC equals to 3. Let M be the midpoint of hypotenuse BC. Point I and point E lies on the side AC and BC respectively, so that AI is greater than AE, and AIME is a cyclic quadrilateral. Okay, cyclic quadrilateral. Given that the triangle EMI has area of 2, you see, an area, the question already gives you the area. A triangle has area of 2. And the length CI can be written in such a form. CI can be written in A minus under root B over C, where A, B, C, there are positive integers, and B is not divisible by the square of any prime. Then what is the value for A plus B plus C? So before we jump to the question, I'd like to show you guys, this is actually a typical AMC way. Typical AMC way to ask you the length of CI. It's very common that AMC, as long as AMC like to ask you what is the length of CI, they never directly ask you for CI. They always say CI can be written as A minus under root B over C, or even CI can be written as M over N, while M and N are co-prime, blah, 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 and then ask you to determine M plus N or A plus B plus C. This is a typical AMC way to ask you. And the reason is very straightforward. AMC does not want you to measure it. If I directly ask the value for CI, you can pull out a ruler, do some scaling to measure it. But as long as I ask you to M plus N, you have no idea how to measure. So that's a way, just try to block the students from guessing. But nevertheless, the question is asked you to determine what is the length for CI. Okay? So how to do such a problem? As a common practice, as long as you see any geometry problem, your first reaction is try to make sure you have a clear and quite well-organized graph. Okay, the graph needs to be as accurate as possible. So therefore, you can do some guess or kind of like imagination or inspiration from the graph. So let's try to do the graph. You have a what? A right isosceles triangle, right? And you have an M point in the middle of the hypotenuse. And you want to make this way. Okay, let's see. This is going to be our, this is color. Okay, this is going to be A, B, C. Okay, C. And this is M, this is E, this is I. Okay? So the question already give you that AB equals to AC equals to 3. This is 3. This is also 3. It's isosceles triangle, right? And this is the midpoint. Okay, I have all the information here. Well, there's actually a weird condition here. AIME is a cyclic quadrilateral. Okay, this is actually going to be my first question. How I should use cyclic quadrilateral? How to use such a condition, right? I think this is quite common that you can think about what to do. Well, moving forward, the question gives you another condition. EMI, triangle EMI has an area of 2. EMI is actually a triangle here, right? So this triangle has an area 2. How to do with such a condition? So normally speaking, let's try to do this one by one. So this is actually the thinking process. I like to teach you guys how to do the thinking process. As long as the question gives you a condition, there must be some reasoning behind it, right? There won't be any condition given for fun. There must be some underlying reasoning for it. Cyclic quadrilateral, we need to think about how to use this. Second is, if I give you an area of a triangle, normally, you know, in order to determine the area of a triangle, you need to know the height. You need to know the bottom, right? Normally speaking. But the question directly gives you a triangle with an area 2. In Chinese, we have saying, right? 这个叫什么？就是事出反常必有妖. In English, how can I say? If you see something doesn't make sense, there might be something under the table, right? Something like this. So we need to use why the question directly give you like EMI triangle has an area 2. So as long as you figure out the reason for this question, these 2 questions, you'll be able to solve the problem fairly quick. So let's do this one by one. This is all the thinking process you should have in your head. A cyclic quadrilateral. What is the conditional react as long as you see the cyclic quadrilateral? I think the first one is pretty much using the definition. Means if you have a cyclic quadrilateral, there will be a point, right? Reaches the center. So these 4 vertices will have the same distance for the center, which is almost impossible for this problem, right? You don't even know where the center is. And you have to put a center and make 4 lines. You're adding trouble to yourself. Forget about it. Second one is cyclic quadrilateral always give us something like the Ptolemy, right? Cyclic quadrilateral, you have the Ptolemy theory right after. But Ptolemy theorem is going to involve the EM, AE, AI, MI. This is too complicated. You don't even know anything of them. But you have to know them all, plus 2 diagonals. Again, this is something very tricky as well. Maybe you don't have to use it. Then the third one, as long as you see a cyclic quadrilateral, should be the opposite 2 angles are actually what? Complementary to each other, right? So angle A plus angle, I can say M, EMI, this should be equals to 180 degrees. And also MEA plus MIA also equals to 180 degrees, right? So this is like the common sense. So obviously we decide the first one is too tricky. You can't even find the center. The second one, you have to figure out all the problem, all those sides plus the diagonal. You don't even know this. Maybe the last one is exactly what you need. Okay, this is 90 degrees. So means this is 90 degrees. Okay, this is 90 degrees. And what is my second concern? Why they give you the area for EMI? That being said, EMI is actually a right triangle, right? If EMI is a right triangle, okay, fantastic. So you don't even have to determine what is the height, what is the bottom, right? You already know this is the right triangle. As long as you figure out the EM, IM, you are kind of having a kind of like a routine, right? Such a trace, how to determine the area, and taking from there, you get what you need. So that being said, as long as you answer the first question, you kind of answer the second question as well. Is that right? So this, like the entire process is actually very harmonic. You know this, okay, these two angles, putting them together is 180 degrees. So therefore means this is right. I said this is a kind of right angle. So a right angle, you will be able to determine what is the area by using the two legs. Okay? So moving forward, how can I determine this? Think about it. There's another very important condition you didn't use yet. Midpoint. M is the midpoint. If M is the midpoint, I want to use M to make two perpendicular lines on the two sizes. Of course, these two things, let's say this is F, this is G. Of course, MF is equal to MG, right? This is the right isosceles triangle from the midpoint of the hypotenuse, make two perpendicular lines. Of course, they're the same. Okay, think about it. Now I have this line. Yeah, they recently changed the layout. You have this line equals to this line. Okay, you have a 90 degrees here, have a 90 degrees here, which give me a feeling maybe these two triangles are kind of congruent to each other, right? I don't really know yet. I still have to get another condition to confirm with me. But it really gives a feeling they might be congruent to each other. Okay, how to prove they are congruent to each other? How to prove they are congruent to each other? Actually, again, we're going to use such a condition. This condition, we just use it once, which is not enough. We're going to use it twice. See, if this is a cyclic quadrilateral, let's say this is angle 1, this is angle 3, right? Let me change different color, angle 3, angle 1. So cyclic, you're going to have angle 1 plus angle 3 equals to what? 180 degrees, right? Also, angle 2 plus angle 1 also equals 180 degrees. So therefore, angle 2 equals to angle 3. Okay, voila. Now you have angle 2 equals angle 3 plus FM equals to MG plus a right angle equals to right angle. So therefore, triangle FME is actually congruent to triangle FME GMI. Is that right? So that being said, okay, these two guys, let me change a different color. Oh, oops, sorry. These two guys are also the same, right? They are the corresponding side for a congruent triangle. Okay, EM equals to MI. Don't forget, I just proved EM is perpendicular to MI. So, okay, so this triangle is such a special triangle. It's a right isosceles triangle. The question says, EMI triangle has an area 2, right? So that being said, you will be able to know EM equals to MI equals to 2. Is that right? Okay, this is 2. If I change the color here, 2. Well, the question asked me to do what? Don't forget where I come from. Don't get lost. My question asked me to determine the value for CI. CI is where? CI is here. This is my CI. Okay, I know what? I already get MI equals to 2. Let me just drag it out. Okay, if I move out this is M, this is I, this is C. MI is equal to 2. This is what I just proved. The question asked me to determine the value for CI. This is a right isosceles triangle, so angle C equals to 45 degrees. Also, the question already gives you the lengths for AB and AC. Then you will be able to determine BC using the Pythagorean theorem. So therefore, you have already know what is the value for CM, right? CM should be equal to 3 under root 2 divided by 2. That's a quick calculation. You figure out by yourself. Okay, now you are kind of doing what? An angle, like a triangle with angle C given, the other two sides given, you just determine CI using what? Cosine law, right? Cosine law. You will be able to determine 4 squared plus x squared 9 over 2. I'm just going to give you the answer directly. You don't have to calculate too much. So x will be equal to 3, 7, 2. So this is exactly what you have for CI. So correspondingly, this is A, this is B, this is C. So A plus B plus C, the question will be D. Okay, so far, so good. So every single step, you need to have some conditional react. These things are actually hinted by the specific condition. Okay, this is our first problem. Okay, if all good, let's continue to see another problem. Exactly the same strategy. Second problem is a problem from, there you go. That's our second problem. A second problem is a problem from 2010, Amy 2, question number 9. Okay, our lecture is Amy AMC combined bootcamp. So you'll be able to see 40% problem from Amy, 60% problem from AMC. Okay, that's the big arrangement for our problem. Okay, let's check out what is that. So this problem says you have a regular hexagon, and you have a bunch of midpoints on different sizes, A, B, B, C, blah, 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 respectively. And then you made some weird connections. So this kind of weird connections create a smaller regular hexagon. Later, I'll show you the graph, then you'll understand where it come from. A big hexagon, you make the midpoints, and then you do some weird connection, you figure out another hexagon. Okay, the question says, let the ratio of the area of the smaller hexagon to the area of the big hexagon can be written as m over n, while m and n are relatively prime positive integers. Determine the value for m plus n. Okay, so like I said, all the AMC and Amy step number 1 is you need to figure out what is the correct, shape, right? So let me just help you to give you the shape. We can have a look at it, how we're gonna do with such a problem. So you have such a B, C, D, E, F, okay? And the question give you a bunch of midpoints and then ask you to do a connection. I'm gonna show you how to do all those connections. So it's kind of like this. You always make a vertex and make it connected to the midpoint of the adjacent side. Something like this. Okay, this is, you're gonna have G, H, I, J, K, L. Okay? So as long as you finish such a shape, you will be able to construct out another hexagon. Another regular hexagon goes like here. You see? The little one in the middle. Okay? The red one in the middle. And the question is asking you to determine what is the area ratio between the smaller one and the big one. Between the smaller one and big one. I'll show you guys how do you think as long as you see such a problem, okay? Apparently these two hexagons, they're not touching each other. One is actually like scrambled in the middle, right? The other one is outside. So, you know, as long as you want to do some comparison between them, right? There must be touching each other, right? They must have some relationship. If one is scrambled in there, has nothing to do with the outside, there's no way for you to do. But before we jump to that part, I think observation is always our #1 step for all these entire math related problems. The first observation for this problem, I think we can see these two hexagons, they're kind of very close. And also they are sharing the same center, right? The big hexagon and the small hexagon, they are sharing the same center, right? This is a quick observation. Second observation, the question asks you to determine the area ratio of those two hexagons. Before we jump to the calculation of the area, I think all the hexagons, they are similar to each other. Is that right? All the equilateral triangles, all the squares, they're similar to each other. As long as you know they're similar to each other, your first conditional react will be, if two shapes, they are similar to each other, the area ratio will be the similarities ratio's perfect square. Is that right? Area ratio will be equals to similarity ratios perfect square. Okay, I think we're kind of one step forward. That being said, as long as I figure out a similarity ratio between these two hexagons, maybe my work is done, right? Maybe my work is done. How? So the $1 million question is, how can I find out the corresponding size of these two shapes? You can use the shape AB, right? Like side AB as the side, or any kind of corresponding side, maybe two heights. If two triangles that are similar to each other, right? The heights, they will be considered to be the corresponding size, right? Their ratio will be the similarity ratio. So how to find that? I think intuitively, what you can do is you can kind of do some connection, right? If you do not do any connection, well, how can you figure out the work? So what I will do is I'm going to do some connection from here. Connect OA, then connect OH, then do a perpendicular line to AH. I'll show you why. This is O, this is M, right? And this is H. Of course, this is going to be 90 degrees. So that being said, what is the corresponding size for my two regular hexagon? One is this guy, MO. MO is actually kind of like the distance between the center to the small hexagon's side, right? The other one is OH. OH is actually what? The distance between the center to the big hexagon side. So as long as you can figure out OM over OH, this is kind of your similarity ratio. Is that right? So we'd like to do it as easy as possible, not as complicated as possible, right? So let's try to figure out how to determine the value for OM, how to determine the value for OH. So try to make our life easier. We can let AB equals to 2. It doesn't matter if you want to let AB equals to under root 45 or under root 46, 47, it's up to you. But I want to make it as easy as possible. So we let AB equals to 2. If that one is 2, so OA will be also 2. Is that right? And the BH will be 1. Okay? BH will be 1 because H is the midpoint of BC. Okay. It looks like most of my magic will be happening here, right? Kind of like in this region. That's all my magics. Okay. Now I know here. Let's have a quick look. All those kind of problems, you just try to calculate as much as you could. Let's check out for this region. This region. You already have AB equals to 2. BH equals to 1. This is what? 120 degrees, right? Then using cosine law, you will be able to determine the value of AH. Is that right? Cosine law, you will determine AH. AH is under root 7. Under root 7. AH, I know. Okay, let me use this. This is AH under root 7. Okay, under root 7. Okay, what else I can determine? Can I determine OH? Is there a very quick way for me to determine OH? AO is already there. AH is already there. Yeah, I see somebody already give the answer for OH. OH is easy to determine. Check it out here. I do a connection for OC. This is 2. This is 1. This is what? Under root 3. Is it right? OH will be under root 3. Voila, in that part, let me just do it from here, okay? Let me drag out entire thing from here. This is my A, this is my H, this is my O, right? I already know AH equals to under root 7. AO is equal to 2. OH is under root 3. And I need to determine what? The height for the hypotenuse. Okay, this is no, I mean, there's no hypotenuse, but like AH, right? The height on AH. What is that? This is going to be my OM. Do you still remember? I just mentioned, as long as you have a triangle giving 3 sizes, how are you going to determine the height for one of the sides? 2 ways, right? Using either Heron's formula or using the double Pythagorean. It depends on what is the number. This is exactly what I mentioned previously. They give you all those weird numbers. Please do not use Heron's formula, using the double Pythagorean. All right? So with all those information, you will be able to determine OM will be equal to 12 over 7 under root. So the similarities ratio will be OM, OH, this is OM, this is OH, right? Will be 4 and over 7 under root. So the area ratio will be exactly the perfect square, which is 4 over 7. Is it good? So we're actually using cosine law one more time, right? And also the double Pythagorean theorem we introduced previously. These are all the common sense. Take it as a conditional react, and you will be able to do a lot of problems fairly quick. Okay, so far so good? If all good, let's go to another problem. The third problem in this part. This is also a problem from 2010. Amy 1, question number 15. This is the last problem from Amy. It's a little bit difficult, but again, if you understand the flow, there won't be something too complicated, and you will be able to figure it out by yourself. This problem says like this. You have a triangle. Let me change the color. Oops. I think like recently they changed a new. They actually changed a new model for this. Okay, good. Now it's good. You have a triangle, ABC. Okay, so this triangle already give you 3 sizes, AB, AC, AB, whatever. And let M be a point on the AC such that the yin circle of AMB and BMC, they have equal radius. What is that? So it looks like we have such a M point here. Let's say this is A, this is B, this is M, this is C, such that the yin circle from here and the yin circle, let's say from here, they're actually doing what? They have the same radius. So let me just try to give the graph. If I give the graph a little bit precisely, something like here. I have, this is 1, 2, 3, right? This is my yin circle. And maybe here is, this is 1, this is 2, this is 3. Everyone has the same radius, R, 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 R. Okay, AB is 12, BC is 13, this is 15. Okay, with all those information, the question is asking, what is AM over CM? AM over CM is P over Q, where PQ are prime numbers, blah, 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 and then determine what is the value for P plus Q. Okay, this problem, how can we think? It's a $1 million question. How can we think for such a problem? This problem looks like pretty brief, right? You have like 2 circles, that's it, and then try to determine AM over CM. I think for most of the geometry problem, our big direction is what? Try to calculate whatever you could, right? And gradually by gradually, you might kind of like, kind of like surprise. You see, oh, okay, there is something hidden there. So what we can do at this moment, because we know these are yin centers. So if I do a connection, this is going to be what? This is going to be an angle bisector, right? If I do a connection, this is going to be what? This is angle bisection, like an angle bisector. Like I said, I really have no idea how to deal with that, but at least the only thing I can start with is pretty much do some cosine law to figure out what is the cosine value for 2 alpha, cosine value for 2 beta. That's pretty much all the condition I can do from there, right? Otherwise, I have nothing. So cosine law, you can say cosine 2 alpha, cosine 2 beta. This one is easy. You can actually calculate what is the value, right? I think one is 5 over 4. The other one is 25 over 39. This is no magic, right? You just do it by yourself. And apparently, there are not so many things I can do. That's it. That's everything. And then the question asked me to determine AM, CM. Maybe, I just say maybe, in order to determine this AM, CM, I might be able to determine R first. If I can determine R, maybe using the Pythagorean gradually by gradually, I will be able to determine AM, CM. I'm just saying maybe, okay? There's no guarantee. Okay, if I want to determine the value for R, what can I do? R is kind of like in all those kind of little triangles, right? here and there. How can I get a relationship from something I know and something I do not know? This is a question I'll be asking you for the entire lecture. Something I know is cosine 2 alpha, cosine 2 beta. Something I do not know is R. Is there a kind of thing helping us make kind of a relationship between this kind of R and alpha beta thing? I think this is not so conspicuous, to be honest, right? Not so conspicuous. And one more step. At least in order to determine the value for R, I need to do some trigonometry related to alpha, beta, right? And what I know here is cosine 2 alpha and cosine 2 beta. So intuitively, I need to reduce the 2 alpha into maybe alpha first to make my life easier, right? Let's say from cosine 2 alpha, it has three ways to be reduced. Can be 2 cosine square alpha minus 1, 1 minus 2 sine alpha, or 1 minus tangent square of alpha, and 1 plus tangent square alpha, right? There are 3 ways to reduce the order from cosine 2 alpha to single angular. But as long as I choose sine, cosine, these kind of things, I'm gonna have to deal with a hypotenuse, which I totally have no idea where does it come from. And it has nothing to do with R. So maybe I'm trying to use tangent alpha, can make my life easier because I'm gonna use R and I'm gonna use like something here, right? Maybe I still have to use it in the future. I don't know. I'm just trying my best to see if this is gonna work or this is not gonna work. This is the thinking process. If that's the case, let me just try to do it. Cosine 2 alpha equals to 1 minus tangent square, 1 plus tangent square equals to what? 5 over 4, right? You will be able to determine tangent alpha is under root 2 over under root 7. Same thing, cosine 2 beta. Exactly the same thing, right? This is pretty weird, but you have tangent beta equals to under root 7, 4 under root 2. Okay. Moving forward, let me try to do something like this. Tangent alpha over tangent beta. This is going to be what? 8 over 7, right? You just plug in the value. You will get 8 over 7. That being said means what? Means, let's say I'll give a name. This is P, this is Q, right? It means AP, CQ. Tangent alpha over tangent beta, CQ is here, AP is here, equals to 8 over 7. You know what? Because my goal is try to determine AM and CM eventually. So if I know AP and CQ, that's pretty good. I'm actually one step forward to what I need, right? In that case, I'm gonna let AP equals to 7x, CQ equals to 8x. This is not a magic. I just want to make my life a little bit easier because 7 to 8, this is not a very easy calculation. So 7x, 8x. Let me try. Okay, this is gonna be 8, right? And this is going to be 13 minus 8x. This is going to be 7. This is going to be 12 over 7x. If this is 12 over 7x, this is also 12 over 7x, right? 12 minus 7x. This is actually, let me change the color. If this is 13 minus 8x, this is also 13 minus 8x, right? So this tiny, tiny one here is going to be what? 1 minus x. Is it right? Okay. I still didn't get what I need. I need to have like more things there, right? How can I do next? This is actually another thing. Because I need to figure out what is the value for, let me change the color. What is the value for X? What is the value for R? Maybe I also have to figure out what is PM, what is MQ, right? PM and MQ. I'm going to give a name. Maybe I'm going to call this is M, this is N. One is PM, one is MQ. I need to know everything in order to do what I need to do, right? So let me figure out how can I find out the relationship for all those weird segments. I think the first relationship I can find out is here. Everything adding them together is 15. Is that right? M plus N plus 7X plus 8X equals to 15. Okay, this is my first relationship. Second relationship is easy as well. We just spent so much time talking about the tangenta, right? We determine the value for tangenta. We need to use it because tangenta equals to alpha equals to R over 7X, right? So tangenta alpha R over 7X equals to under root 2 under root 7. And then tangenta beta, it's, yeah, as long as you have one tangent alpha, I think it's good because tangent beta is exactly the same thing. They won't give you too much new information, right? Tangent is here. I use it once. It's good. What else? What else I can think about it? This is another magic part. This is the magic part for this problem. Let's check out these two. Let me change the color to maybe black. Let us check out these two quadrilaterals. I'll say these quadrilaterals are actually similar to each other. Do you guys agree with me? This is not something we're using so often. This is a little bit rare. I'll say these two things are actually similar to each other. Why? This is not a magic. See? This is 90 degrees, right? This is 90 degrees. This is 90 degrees. This is 90 degrees. This angle will be equal to this angle. Is it right? And this angle will be equal to this angle, right? So these two quadrilaterals are actually similar to each other. As long as they're similar to each other, corresponding sides will be proportional to each other. Where are the corresponding sides? This is R, R. This is M. This is also M, right? Because this is the yin circle. Don't forget, the yin circle is here. I just didn't really draw it out. So this is N, this is N, this is R. So that being said, R over M is equal to N over R because these two corresponding sides will be proportional to each other, right? You guys follow me? Yes or no? Okay, perfect. This is our third condition. Where's the last condition? The last condition is here. Here is what? This 1 minus x will be what? M over n, m minus n, right? M minus n will be 1 minus x. This is 4 equations, 4 variables. You'll be able to solve it out. Trust me, you can have 2 values. One is x to 2 over 3 or 2. Which one I need to have? Which one I need to get rid of it? Two is not possible. Why? A very quick observation you can find out from here. Check it out. Oh, this line is AC, right? AC equals to what? I'm just gonna put it here, okay? AC equals to 15x plus m plus n equals to 15, right? Then X can be what? X must be lesser than 1. Is that right? So therefore, X must be lesser than 1. 2 is not even possible. Only 2/3 is our good option. Okay? As long as you know the value for the value for 2/3 means X you can figure out. Then M, N, you can both figure out. You're gonna do a lot of calculation. This is a heavy calculation problem because this is the last problem for Amy. So you're gonna have AM over CM equals to 22/23. So these two guys, adding them together is 45. That's the solution for such a problem. Okay, so far, so good. So once again, this is also using what? The cosine law. Cosine law is like this. As long as you have some time to use it, try to use it. Do not hesitate too much. Try to determine whatever you can determine right away. And then within all those kind of relationship, you might be able to find some sparklings. Okay? So this is what I want to say for the first category. Using the cosine law, the similarity, the Pythagorean theorem, blah, 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 in a triangle. Okay? So if all good, let's go to the second part, how to use them in a circle. Okay? So my next problem will be the second part. Using the cosine law, the Pythagorean theorem, the similarity, blah, 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 in a circle. The first problem I will give you is the 2010 AMC 12B, question number 22. There you go. Okay, let's have a quick look at the problem. The problem says, let ABCD is a cyclic quadrilateral. Okay, I said cyclic one more time. Okay, I hate it, but I said it one more time. Cyclic quadrilateral. And inside, like the side lengths of ABCD are distinct integers lesser than 15. Distinct integers. As long as you see integers, probably you're going to do some integer related analysis, some basic number theory analysis later, right? So this is actually a very important conditional react. As long as you see integer, there must be some kind of number theory related discussion later, for sure. Otherwise, how did I bother give you the integer? Such that BC times CD equals to AB times DA, then what is the largest possible value of BD? Again, we start from everything, we're gonna start using our graph, right? We need to give a perfect graph before we can do anything. So the graph goes something might like this. You have a quadrilateral and you have this. This is A, B, C, D. Okay, so this is cyclic and the lengths, they're all integers less than 15. And BC times CD equals to AB times DA. With all those information, the question asks you to determine the longest possible value of BD. All right. So let's think about it. Okay, how do you think as long as you see such a problem? That's the $1 million question I keep asking you guys. Cyclic quadrilateral, we talk about the Ptolemy theorem, we talk about the corresponding, like the opposite two angles are complementary, right? We talk about they all have the same distance for one little center, right? Oh, this time I give you something like this. BD times CD equals to AB times DA. I think most of the people will have the first reaction. Maybe it's time for me to use the Ptolemy theorem, because Ptolemy is kind of like times one times the other equals to another one times the other plus blah, 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 right? If this is your first reaction, it means you are actually learning math good, right? This is a very good direction. But after you think about it, you really want to see like the details, you might find something might not be so happy. Why? Check it out. BC times CD. Let me change the color. BC times CD, okay, equals to what? AB times AD. This is not Ptolemy theorem. Ptolemy will be AB times CD plus AD times BC equals to AC times BD, right? This is Ptolemy, but this is not Ptolemy, right? And not only so, because they're actually like the adjacent two sides, not opposite two sides. This is not exactly what you want, right? And also, if you want to talk something about Ptolemy, you have to involve AC. The question never asks you AC. Don't find trouble for yourself, right? Maybe, again, Ptolemy is not so, what should I say, so preferred, right? Not so appealing for your solution. Can we find something different, or something, I don't know, something I can handle while still using BD, CD, AB, DA? Who can tell me? So let me ask you the question. Who can answer my question? Forget about the Ptolemy. I think we're all done for the Ptolemy. Is there some other rules, some other theorems we talk about recently, blah, 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 and we can do something similar? So student have a question. BD is the diameter? No, BD is not BD is not a diameter. At least at this moment, you have no idea if this is the diameter or not. Triangle BDC and the DAB, they're equal? You mean they are congruent? No, not necessarily. The area? No, as you can see from the graph, right? This is not going to happen. No. Oh, or maybe, yeah. The area, yeah. If using sine law, yeah, they might be similar. However, because you have this distinct relationship, maybe they're very close. Maybe they're very close, right? So, but my $1 million question is that how can I use BC times CD equals to AB times DA? What kind of formulas you learned so far can equip you to do BC times CD and AB times AD? If you figure out the answer for this question, you'll be able to solve this problem very quick, right? Think about it. What kind of technology you learned so far can have this adjacent two sides to a product rather than this Ptolemy's opposite two sides doing a product? Who can think about it and give me the answer into the group chat? Okay, I see somebody has the correct answer. The cosine law. One more time, the cosine law. This is where we come from. We're talking about cosine law, right? Cosine law has the capability to give you, let's say, this is theta. This is going to be pi minus theta, right? Because they are cyclic quadrilateral, right? So you will be able to use the cosine law for this little triangle ADB. You're going to have what? For this little triangle ADB, you're going to have BD square equals to AB square plus AD square. 2AB times AD cosine theta, right? This is the cosine. This is the only technology you have AB, AD, these two adjacent sides times together. The other one is what? If you use the one for the upper triangle, you're probably going to do the same thing for the lower triangle one more time, right? This is triangle BDC. BD square is going to be equal to BC square, DC square minus 2 BC, DC cosine pi minus theta, right? This is equation number 1. This is equation number 2. Don't forget, you have these two parts are the same. BDDC, ABAD. What should I do next? Who can tell me? What should I do next? Now you have two equations. What are you going to do next? This is also a very common practice for the math competition. As long as you have multiple equations, try to manipulate it, right? Plus them together, minus one from the other, multiple them together, or the left over the left equals the right over the right. Just kind of some algebra manipulation, right? I think pretty much everyone have it correct. 1 plus 2. Why? Because this is going to be canceled. Cosine pi minus theta is negative of cosine theta, right? At our level, this basic trigonometry identity, we don't have to say too much, right? So 2BD square equals to AB square plus BC square plus CD square plus AD square, right? This is easy, yeah? We just cancel out like all the cosine thing. Okay, it looks like it's very promising, huh? We really have something. We have, the question says what? These quadrilateral, the side lengths of ABCD, they are distinct integers, lesser than 15. And the question asks you the biggest value for BD. Okay, so that means that this, they're all lesser than 15, right? So you want me to determine the biggest value for BD. Can I just say 14, 13, 12, 11, and that's it? The biggest value, they're distinct, they're lesser than 15, and we just pick up the biggest 4, like the big 4, right? Like you know, the big 4, like the counting form, right? Like we just choose the big 4, and then that's gonna be the value for BD. Is it gonna be the correct answer? Or there might be some other little tiny things you need to think about. Can't be prime larger than 7. Can't be prime larger than 7. Yeah, I think Andy has a very correct direction, but I don't even know, but I don't want to, where does prime larger than 7? So you mean they cannot be prime numbers larger than 7? They're all like smaller numbers? You mean like 1, 2, 3, 4? Or cannot be a prime number larger than 7, so the largest number of the prime number must be 7. Yeah, I think, okay, perfect. Andy has the correct direction. I think most of the students, whenever they come to here, they're so happy. They just directly put a number and find from ABCD. Trust me, there must be like an ABCD option, just directly calculating this out, because they're waiting for you just for this. But here, there's one tiny thing you need to go before you choose this as the answer is, don't forget, BD. BC times CD equals to AB times DA. Means these four numbers cannot be so flexible. There must be some constraints in between, right? If you plug in 14, 13, 12, 11, there's no way to make sure these two of them times together equals to the other two. So how to do that? This is only a tiny thing. We like to do ASAP, right? As big as possible. So I'll maybe choose BC as 14. It doesn't matter, right? I choose the biggest one possible. As long as I have a 14 on the left-hand side, 14 is written as 2 times 7, right? I don't care about 2. 2 is like so common. But 7, all the positive integers from 1 to 14, there are only two numbers have the 7 factor. One is 14, the other one is 7 itself. So that being said, what means what? On the right hand, there must be a 7 there, right? In order to make the equation holds. So that being said, you are still looking for one number and another number. Make sure the right is actually twice of the left if this is right. If this is left. Right? Because you still have a 2, right? This 2 must be here as well. So what is the largest number? Make sure right is twice of the left. For sure, 1 is 12, 1 is 6. That's it. So these four numbers are 6, 7, 12, 14. You cannot be so flexible to whatever you want to be. So far, so good? Okay, if all good, let's go to another question. You see, this is actually again, a very common practice, a common application of the cosine law, right? So as long as you're dealing with the circles, cosine law, never forget, and also the cyclic. So somebody 不是直角色语义决定你怎么知道哪个分子 okay, like student asked me a question in Chinese, I'm going to say, if this is not a right isosceles triangle, if this is not a right triangle, if I use the cosine law, how do I know which side is the numerator? Cosine law has nothing to do with the right triangle. Any kind of triangle can have cosine law. A, B, C. This is A, this is B, this is C, right? So cosine, let's say cosine B equals to A square, C square minus B square, 2AC. It does not have to be a right triangle. Cosine law is something like this, right? I think you guys should be very familiar, right? Cosine law is something like this. Well, I think when you're talking about a right triangle, you're talking about cosine, right? Cosine. If this is theta, cosine theta will be A equals to C. Cosine law and cosine theta are actually two different concepts, right? Cosine theta, you must have the right triangle thing to do the calculation, but cosine law is actually valid for all the triangles. It does not have to be right triangle or acute triangle or like so on and so forth. Okay, so far, so good? If all good, let's go to another problem. The last problem I'm going to give you is a problem from 2018, AMC 12B, question number 25. This is the last problem from the AMC, and let's have a look how to use the technology we introduced, and how to use the technology we introduced to solve this problem. Number 2 is here. There you go. The problem looks like a little bit nasty, but if you scratch the surface, I understand the essence of this problem. So easy. So this is a problem saying they have 3 circles, omega 1, omega 2, and omega 3. Each one has a radius 4. Okay, they're all congruent to each other, right? They're all radius 4. And they're placed in the plane so that each one is externally tangent to the other 2. This is quite understandable, right? And the point P1, P2, and P3 lies on omega 1, omega 2, omega 3, respectively, such that P1 equal to P2, P1, P2 equal to P2, P3 equals to P3, P1. This is what? A equilateral triangle, right? This is an equilateral triangle. And a funny thing is here, Pi plus 1 is tangent to omega I for each I equals to 1 to 3, where P4 is equal to P1. What are they trying to say? They're trying to say something like this. Let's say, I'll change the P3, P1 is actually tangent to omega 3. P1, P2 is actually tangent to omega 1. P2, P3 is actually tangent to omega 2. Okay, it's just basically kind of like a cyclic, right? It's a cyclic tangent. With all those information, the question asks you to determine the area of this triangle P1, P2, P3 in the form of under root A plus under root B, and what is the value for A plus B. Again, like the same thing, you need to determine the area of this equilateral triangle. Okay, the area of this equilateral triangle. Okay, how to do such a problem? First thing first, if you want me to determine the area of equilateral triangle, I just have to know A, right? Because the area will be under root 3 over 4A squared. Is it right? Everyone knows that? Equilateral triangle, give you a side, the area is under root 3 over 4. Okay? So my goal is trying to determine P1, P2, or P2, P3. Oh, good. But it is kind of in the middle of nowhere, right? How can I really put them together? Again, like I mentioned previously, for all the geometry problem, you just try to determine as much as you could. And then magically everything put them together, you get what you need. Okay, how to determine as much as I could? Do you still remember at the very beginning of our lecture, I said, as long as you see tangent, there are normally 3 things for you to do. One is to make the connection. Let me do a quick review, okay? Because we're talking about this every day in our regular lecture. I'm just gonna tangent. 3 things. First one, connect the center to the tangent point, right? Second, connect 2 centers. In our case, it is possible because you have 3 different circles, right? Third one is actually using the tangent secant. This is power of point, right? Tangent secant. But I don't think that one is too useful for now because it looks like you do not have a very clear idea what they are. But at least the first 2, you should do it right away without thinking too much. Is it right? So without a loss of generality, I'm gonna find here, maybe I'm just gonna do 2. First thing first, maybe I'm gonna give this as a B, this is C, right? I'm gonna do a connection between 2 circle centers, right? And then what's next? I'm gonna do a connection between the center to the tangent point, center of the tangent point, right? These are all perpendicular to each other. Okay, no magic. Using whatever we introduced as a conditional react, you don't have to think too much. Okay, at this moment, you don't think too much. Moving forward, let me think about it. how can I use the condition given by the question just to figure out whatever I need? I'm gonna do a little magic here. I'm gonna extend this and extend this. This is the only magic I do. Trust me, I promise. I won't take any magic afterwards. Why I'm doing this? Let's think about it. Let's think about P1, P2, P2, P3. P1, P2, let me change the color, maybe to blue. P1, P2 is here. P2, P3 is here. Okay. From P1, P2 to P2, P3, this is 60 degrees, right? This is the included angle, 60 degrees. Okay. BD is what? BD is perpendicular to P1, P2, right? C, like a BP1, excuse me, BP1 is perpendicular to B1, B2, right? CP2 is also perpendicular to P3, P2. If these two lines are including for 60 angle degree, so the two heights will be also have a 60 degree excluded angle, right? Is that right? This is, I think this is a common sense thing, right? This is not something too complicated. Is that right? Okay, but if that's the case, it really gives you a lot of interesting things. Think about it. This is 90 degrees, right? This is one line, even though I didn't make it so nice. This is one line, right? So if you let this guy equals to x, this guy is going to be under root 3x, right? The entire thing is going to be 2x. Is it right? Okay, it's kind of like similar with some of the things we mentioned previously. You already have this x blah, blah, blah. Maybe you just have to do some equation, right? Figure out the equation and try to figure out what's the relationship and then figure out what it is. Because the question give you the radius is 4. Maybe try to find a relationship. This is 4, right? Find a relationship between all of them, or you're good to go. Okay. I need to have an equation. How to get an equation? Of course, you want to do the equation within the triangle, right? The triangle is gonna help you do the equation. I have already, let me use this color, do some discussion on this triangle A, P2, P1, right? This is P1. A, P2, P1. I get my x, 2x, under root 3x, right? It looks like I think this triangle is already done. Finish, just pretty much finish its job. I don't have too much thing to get it from there, right? 那中文说就没有什么油水了，从这个 triangle 上 they're all done, right? So let's try to find out maybe some other triangle is going to help me to finish my work. And then voila, everything is done. Then who can tell me which triangle is the triangle what I'm looking for? Who can tell me? This is, as long as you answer this, your work is done. You solve out this problem right away. There are not too many triangles in this graph, right? I have already used up all the technologies for this red triangle, A, P1, P2. Apparently, I cannot use the triangle P1, P2, P3, right? This is exactly what I'm looking for, right? What is the remaining triangle I can work with? Okay, I see many students have the correct answer. Triangle, let me use the color, maybe green. Oops. Triangle ABC. you do not have too much triangle. This is pretty much the last triangle you can dance with, right? The last triangle is triangle ABC. A, B, C. Let's check it out. AB equals what? 4 plus X, right? BC equals what? 8, 4 plus 4, right? Because they are two radius. And AC equals what? AC is 2x minus 4, right? And this is what? 60 degrees. Again, you want to use the cosine law one more time, right? Cosine law one more time, and you will get a value for x. X is pretty nasty. As long as you know the x, you will be able to determine, moving forward, you'll be able to determine what is the value for this guy, right? The side is actually under root 3 times x. And then you will be able to determine the area of the triangle. Is it good? So this is the thinking process. Because I'm already used up the red triangle, there's not too much thing I can do for it. I must find another triangle. I can't use the green one because the green one is the one I'm actually supposed to do, right? And that's asked by the question. So I must use another one. So every single step, this is a thinking process. You connect everything together, you will get what you need. All right? So for the entire lecture, we're going to be talking about how to use this thinking. How do you think for each problem? You're not randomly hop up here, hop up there to get an answer. You're trying to figure out what is the conditional react after this. So we're going to use the next 9 lectures talking together how to set up this conditional react. All right. So that being said, we actually finish our first lecture talking about the 2D geometry. We talk about the triangles, we talk about the circles, and moving forward, I'm going to be able to provide you guys the second lecture. We can go to the 3D geometry, which is quite similar to the 2D geometry, and moving forward, how to deal with the coordinate geometry. All right, I think that's pretty much for today's lecture. You have any questions for me? All right. Okay, cool. In that case, okay, I think everyone has, okay, no problem. I'll post a note into like the Google Classroom. And if you have any more questions, you'll be able to let me know. Okay, student asked me, what is gonna do with the final result? Why you know the X and then you know the result? Okay, here's the thing. Whenever you know X, then you will be able to use this guy, P1, P2. P1, P2 is actually under root 3x, right? We have already give you guys the relationship. As long as you know P1, P2, the area will be under root 3 over 4 P1, P2 perfect square. So this is 2 steps from X to know the length, the side length of the equilateral triangle. And from there, you'll be able to know the area of this. Okay, I'll be able to post the note into our Google Classroom, and you'll be able to review it afterwards. All right. Okay, students still don't understand why. Because the question asked is A plus B. Oh yeah, because, okay, I think I just skip a little bit. As long as you know the area of triangle P1, P2, P3, and you will be able to write it into the form under root A plus under root B. So I'll give you the answer. Yeah, no problem, I'll let you know. P1, P2 is actually under root 3, 2 under root 3, 2 under root 7. So you will be able to determine the area of P1, P2, P3, which will be under root 300 plus under root 252. In that case, this is going to be A, this is going to be B. So A plus B will be equal to 552. The correct answer for this problem is 552. Does it answer your question? Okay, perfect. Yeah, any question, just let me know, and I'm here to help you guys. Okay, so in that case, that's pretty much for today's lecture. So I wish you guys enjoy the rest of the weekend, and I'll see you guys for next time. All right, bye guys.